Welcome to the live session of this course, Expansive Soil. Hope you have enjoyed this course for last 8 weeks. And if you have any question, please type it here so that I can answer to your queries or doubt, anything, whatever you have. So you can type here, I will try to answer all of your questions. In the last live sessions also I tried to answer some of your questions which you have posted on that link, or also you posted on the, or you send an email to us, and I tried to answer. So if you have any other questions related to the course, then please write it here. I hope you have learned something about the expansive soil in this course, and you might be now knowing how the soil swells, how it shrinks, and how to determine the swelling properties, the shrinkage properties, what are the diffuse double layer thickness. You might have learned about the clay mineralogy. And also the most important thing is how to design a foundation on expansive soil and how to treat an expansive soil in the field. So I covered all these materials or different chapters in this course. Generally this course was divided in 8 modules. The first module was the introduction to soil mechanics. Since many of the students are not from the civil background and they're taking this course, so just the purpose was to give some initial idea about the soil or the soil mechanics. So in the first module, this module number 1, which was named as Introduction to Soil Mechanics, I covered like the formation of the soil, the index properties, and the soil classification, engineering properties of the soil. So these are the basic things you must have to learn in order to better understanding on the chapters of expansive soil or different topics of expansive soil. Formation means how the soils were formed and what are the different methods of formations, how the soils breaks into small pieces, the different methods of decomposition or weathering, and how these are transported. Those things I covered. Okay, I got the first question which says that how the dielectric constant of pore fluid affect the permeability. As you know that the diffuse double layer thickness controls the swelling behavior of the soil. When the soil swells to a higher value, the permeability will be less. And if we look into the Guy-Chapman's diffuse double layer theory, the diffuse double layer thickness is directly proportional to the dielectric constant. That means higher will be the dielectric constant, higher will be the diffuse double layer thickness. And higher will be the diffuse double layer thickness, higher will be the swelling. So when the soil swells more, it will cover the pore space which available for the flow of water in a more complete manner. So that means it will restrict the flow of water. So in other words, the hydroelectric conductivity will decrease. So therefore, higher is the diffuse double layer thickness, then higher will be the dielectric constant, higher will be the diffuse double layer thickness, higher will be the swelling, and lower will be the hydraulic conductivity. In the class, I explained about different pore fluid. Say for example, carbon tetrachloride, which has a dielectric constant of 4. So when we put an expansive soil into this carbon tetrachloride, the diffuse double layer thickness reduced significantly, or it gets collapsed. So therefore, the swelling of the soil becomes very less. When the swelling becomes less, the hydraulic conductivity increases faster. And on the other hand, on the other extreme end, when we take water, which is a dielectric constant of 18, when you put a soil, expansive soil particularly, into water, the swelling of the bentonite will be more, or when swelling of the expansive soil will be more, and the hydraulic conductivity will be less. So, to summarize the thing, the permeability of the soil is inversely proportional to the dielectric constant. Higher is the dielectric constant, lower will be the permeability, and lower will be the dielectric constant, higher will be the permeability. I hope I have cleared you out. So again, talking about the courses, in the first module, I also covered the engineering properties of the soil, and we need to understand the engineering properties in order to know the different behavior of the soil, and also the soil classification, like how the soil can be classified as far as Indian standard or ASTM standard is concerned. So, what are the basic criteria? What are the general guidelines of classification? So, all these things were covered in the first module. Then, in the second module, I discussed about the clay mineralogy. The clay mineralogy is the, we can say, like a DNA of soil. So, that controls all the behavior of soil. So, without knowing or without having any idea on clay mineralogy, it will difficult to understand the soil behavior. So that's why I covered the topic clay mineralogy, in which I gave an introduction to different clay minerals, like their basic units, octahedral unit, tetrahedral units, how those are combined together in 1:1 or 2:1, 2:2 to form different type of minerals. What are the different properties of those minerals? Particularly, I covered three different minerals like elite, kaolinite, and montomonite. Because I covered those things, as montomonite has the highest swelling capacity, whereas the elite and kaolinite don't exhibit that much of swelling tendency. So that's why I covered the montomonite, elite, and kaolinite. And also I discussed about their various properties like specific surface area, the liquid limit, the free swelling, and also the permeability or compressibility behavior. And in the third module, I discussed about the introduction to, I gave an introduction to the expansive soil. Exactly what is the meaning of expansive soil? You might have seen the expansive soil, but to view the things or view the problem in terms of an engineer, you need to understand what is the exact problem the expansive soil creates in the field. So that, with that purpose, the module 3 was introduced to give an overview of the problem associated with expansive soil. The main problem related to any expansive soil is its water content. When there is a change in the water content, the soil swelling or shrinkage tendency will change. So, for example, with an increase in the water content, the swelling tendency will increase, and with decrease in the water content, the shrinkage tendency or shrinkage of the soil takes place. And if this thing takes place non-uniformly, then the soil or then the soil will have differential settlement or differential heaving. That means one part of the soil under a foundation will swell to a higher level in comparison to other parts, or one part of one part of the foundation will settle in a more way in comparison to the other part of the foundation. And if that happens to any structure, then there will be a tilting of the structure will happen. And if the structure gets tilted, then it will give distress to the structure. And also this swelling shrinkage phenomenon takes place regularly. That means during the wet season, the soil swells. During the dry season, it shrinks. So therefore, if this process repeated again and again, the structure above it gets stressed, and we can see in the form of different cracks or collapse of the structure. So in the fourth module, I try to explain how the swelling of the soil takes place. That is the swelling behavior of expansive soil, the name of the fourth module. So it was started with the mechanism which related with the soil water interaction. That means when this expansive soil comes in contact with water, then how exactly it behaves? What is the reason behind the swelling of the soil? Why not all soils swells? Why only a particular type of soil swells? So those things I explained. And also, when we talk about swelling, what are the different stages of swelling, like osmotic swelling, inner crystalline swelling, and how these are controlled by the different pore fluid. So those things I covered. Then the main criteria or main equation which governs the swelling of a soil is the diffuse double layer equation. Diffuse double layer means when the clay absorbs water, it will form different types. It will form a layer kind of things. Like you can see a distribution of cation and anion from the clay beds. So that is known as the diffuse double layer thickness. So depending on the thickness of the diffuse double layer, the soil behavior will be different. Higher is the diffuse double layer thickness, higher will be the swelling, higher will be the liquid limit, higher will be the plasticity index, and so on. So therefore, any change in the diffuse double layer thickness will also changes this behavior, like compressibility. I'm talking about engineering behavior, compressibility, then hydraulic conductivity, shear strength, and about the index properties means the liquid limit, the free swelling, and what are the different factors which controls the diffuse double layer I discussed in that portion. So all those factors which controls the diffuse double layer thickness can also controls the shrinkage, can also controls the swelling and shrinkage behavior. And how do we classify the soil based on its different properties such as plasticity index, clay fraction, or differential free swelling, swelling potential? Because we need to classify the soil based on its swelling tendency, so that people, when we classify the soil, the people will understand how problem or how big problem this soil can create. So that's the main purpose of classification and prediction. Like if this is the index properties or if this is the swelling properties, then what are the chances or how much the soil is going to swell or how much the soil can shrink. So those things we need to understand. So basic purpose of that one was to classify and predict the swelling behavior based on those parameters. Then I covered the factors which controls the swelling of the soil. Like apart from the diffuse double layer thickness, there are other factors like environmental factors, soil factors can control the swelling behavior of the soil. Say for example, density, initial density, water content. So these are the few factors, and also the loads on the structure, the environmental factors. These are the few factors which can control the swelling behavior. Say for example, when you compact a soil on the dry side of the ONC, the swelling behavior will be more in comparison to if you compact the soil on the wet side of the ONC. So those things I covered in the module 4 lecture, the factor controlling the swelling of the soil. Then in the module 5, I discussed about the swelling shrinkage phenomena of the soil. So in that I talked about the shrinkage behavior, how the soils shrink, what are the different properties which, how these properties will get changed when there is a shrinkage, and what are the different factors which can control the shrinkage behavior. And as I told you in the beginning, there will be cyclic swelling and shrinkage. So therefore we need to understand if a soil undergo regular cycle, that means cyclic swelling and shrinkage behavior, then what is going to happen to the soil? What is going to happen to its swelling potential, then swelling pressure? So those things I covered in the cyclic swelling and shrinkage behavior of the soil. Depending on the water content, the soil can be shrinked into two different stages or two different ways. We can say full shrinkage or a partial shrinkage. So depending on whether it's a full shrinkage or partial shrinkage, the behavior of the soil can be different. Behavior in the terms of the swelling and shrinkage can be different. Then another thing I covered was the behavior of expansive soil. Like what is the thermomechanical hydraulic chemical behavior? How an expansive soil will behave when we put the soil into a temperature, or when we heat the soil, then what are the different changes going to take place on its behavior. So in thermo behavior, I discussed about heating the soil or increase the temperature to different degrees. Say for example, when we decrease up to 100 degree, when we decrease up to 500 degree, when we heating the soil to 100 degree, or when we heat the soil to 400 or 1000 degree, then how the soil is going to behave, particularly an expansive soil. As the soil, expansive soil particularly, consisting of different type of water, diffused water, adsorbed water. So all this water gets evaporated at different temperatures. So therefore, when we heat the soil up to 100 degrees centigrade, the behavior of the soil will be different in comparison to heating the soil up to 1000 or 500 degree centigrade. So that thing I covered, like what will happen to its properties, particularly its grain size distribution, specific gravity, its shear strength. So mostly I discussed about the kaolinite and monotonite because these are the two extinct minerals. Like one is high swelling and another is least swelling. And also I discussed about the hydraulic behavior of this expansive soil, like permeability, and the chemical behavior, like when the soil, expansive soil particularly, comes in contact with different chemicals, then how it's going to behave. So that thing I covered in the behavior of expansive soil. So this is mostly applicable when we use an expansive soil in a landfill liner. Say for example, when we put a liner material in a waste disposal site, then there will be leachate. Leachate means it will be a chemical. It's a chemical liquid which has different heavy metals or organic, inorganic constituents in it, and also its pH is very low. Depending on the source of the waste, its pH can be different. Its BOD COD can be different. So when we put a liner material on a waste disposal site, and when the leachate comes in contact with the expansive soil there, then the behavior of the soil will get changed. So you might be wondering why we want to put a expansive soil in a landfill liner. As you know that expansive soil has a very low hydraulic conductivity, and the purpose of providing a liner in a waste disposal site is to reduce the flow of leachates into the groundwater. So therefore, this layer of bentonite or layer of expansive soil acts as a liner or an impermeable liner to retard the flow of contaminants. And also this expansive soil has a very good tendency to absorb the cations, so or absorb the contaminants. So whatever the contaminants present in a landfill leachates, that can be absorbed by this expansive soil. So therefore, expansive soil, particularly bentonite, is used in a landfill site. But when this leachates comes in contact with this bentonite or expansive soil in a landfill site, then the behavior of the soil gets changed. Particularly, its hydraulic conductivity and the swelling gets changed. Mostly hydraulic conductivity will increase and swelling will decrease. So therefore, in that chapter I discuss about what is the effect of the chemicals on the behavior of the expansive soil. That means when an expansive soil comes in contact with different chemicals, how it's going to behave. And also in the 7th module, I talked about the treatment of expansive soil in the field. Suppose when you go to a site and when you find or when you see some expansive soil, then how will you treat that soil? So there are different methods available, like mechanical methods, hydraulic methods, chemical methods, and treatment by inclusion and the confinement. Of course, I could not explain all the things in details because it's a huge topic by itself. So therefore, briefly I introduce about those four different methods. In mechanical methods, I explain the compaction, which is quite frequently used in the site, and also I used about the surcharge load or preloading, preloading with the vertical drains. Then how you can do that in the field, and when you go for those methods, how the soil changes. So those things I covered. And also when you go for a compaction method, what are the different type of rollers which you can take. And suppose if you are constructing a embankment of the dam or foundation, then what kind of roller you have to use. Because in the field there are many different type of rollers are available, and those rollers are suited for different type of soils. For example, when you use a sheep foot roller, that is most suited for clay soil. So when you use an expansive soil, you have to use that sheep foot roller. If you use the other kind of rollers like a say normal rollers which we can see, then in that case it will create some problem, like it can create some stratification, it may not be able to compact the soil, and since the sheep foot roller uses kneading action, therefore it can compact the soil more effectively, and it can give a large amount of pressure since it has less contact area, and therefore the soil can be compacted quite effectively when you use a sheep foot roller for a clay soil. Then I discussed about the sand drainage and preloading. Mostly again that is more suited for clay soil because the clay soil has very low permeability. So when you apply a structural load on the clay soil, the permeability will be less. As the permeability will be less, the water will percolate or will move through the soil slowly, and that takes a lot of time to soil gets consolidated. And also, as the soil, clay, particularly clay soil, contains more amount of water, so therefore its compressibility will be quite more. That means under a load, it will undergo a large amount of settlement. So if you are going to construct a structure on a clay soil, then what should be your options? Like you just cannot construct a structure without doing any treatment, because say for example if you are not going with any kind of treatment and if you construct the structure, then under the load of this structure the soil will settle slowly and it will take a lot of time for the soil to get consolidated, and also a large amount of settlement will occur. So therefore if you go by preloading method, then the settlement will be created by the preload or the load which you will be applying to the soil before the actual construction. So under that load, the soil will get settled to a large extent, and then you need to remove this load and then you can go for actual construction. So by doing that, what will happen is the actual amount of settlement which you get under the structural load will be less. Okay, so there is a question that there will be any presentation for this lecture. No, there is no presentation for this lecture. Just I'm discussing what I have covered in the different classes. So just I'm summarizing. So if you have any question or anything or any doubt, you can also email to me. I will reply you back. But I don't have any presentation for this lecture. I hope Okay, so when you go for a preloading, then the amount of time required for to reach the final settlement will get reduced significantly. And furthermore, what happens when you apply a load to the soil, the pore water pressure will increase. And that pore water pressure will try to escape out through the nearest drainage which is available to the soil. So suppose if the soil is a clay soil is overlain and underlain by two permeable soil, say sandy soil. So in that case, the water will move to top and bottom. But the time taken to reach from the center point to the top and bottom will be very large. So further you can reduce the time of settlement by increasing the PVD or prefabricated vertical drains. So by providing PVD, the time for water to reach to the nearest available drainage will be reduced. As the time gets reduced, the settlement will take place much quicker. So therefore, you can go with the preloading along with the pre-PVD, that is prefabricated vertical drains. So this is all about the mechanical methods. And then the hydraulic methods. So in hydraulic method, the most important thing in any clay water system is the water. That means if you remove the water, then the soil gets consolidated or the strength of the soil will increase. So in hydraulic method, we try to remove the water from the soil. So that can be achieved in many ways. Like you can go for electrokinetic dewatering. Like again, because in clay soil, the permeability is a factor because permeability is very less time. So time taken to remove the water will be very high. If it's a sandy soil, then it will not be a problem. But even in a clay soil, it will be quite large. So therefore, when you go with the electrokinetic dewatering, so you can remove the water. And you know that clay has different type of cations in it, and okay, so just I got a question. So can you suggest any reference book other than Mitchell and Soga with the effect of different pore fluid on swelling? There are many books available on this. You can take any geoenvironmental books and you will get the effect, where you can find the different study related with effect of pore fluid on swelling and compressibility or permeability behavior of clay. Like you can see geoenvironmental engineering by Sharma and Reddy, and also you can see Expansive Soil by Chain. So those are the few books. I think if you go into all the chapters which I have covered, or maybe you can, if you look into the video slides, at the end I have mentioned about the different books which I have referred. So you can use those books to understand or to know better about those factors. And you can also go through some of the journal papers where the latest research has been carried out on this topic. Okay, I hope that can that has answered your question queries. Just go through those videos. At the end, you will find any reference books which I have mentioned. So those in that those books you can find the effect of different pore fluid on the swelling compressibility and permeability behavior. And also you can check another book, Clay Colloid Chemistry by Van Olfen. So that is one of the classic book on the clay colloid chemistry, where you can see the different mechanism of swelling and also different factors influence which has influenced the swelling. So those things has been mentioned in that book as well. Okay, talking about the chapters, then the hydraulic methods I have discussed about the methods related with electrokinetic dewatering. So as the clay contains different type of cations, particularly exchangeable cations. So when we put some electrodes and when we apply some electrical potential, then those cations particularly move towards the negatively charged electrodes. And those cations particularly also absorb some of the water molecules, as water is bipolar. So the cations particularly, when it moves towards the electrode, it will also bring some of the water molecules along with it. And similarly, the water also try to move towards the electrode, and from there it can be removed. So that's the main mechanism of electrokinetic dewatering. And also I explained you about the vacuum consolidation, how using a vacuum consolidation you can changes the effective stress and thereby increase the strength of the soil. And also then I explained you about different chemical methods like lime stabilization, cement stabilization, bitumen stabilization and fly ash stabilization. And at the end I explained you about the different methods by inclusion and confinement. Like inclusion means you can use geosynthetic, particularly there are various type of geosynthetics are available like geograde, GCL, geomembrane. Those things can be used to increase the strength of the soil. Mostly clay soil possesses very low strength, therefore you need to increase the strength using those methods. And also I discussed about the soil milling. And another method I discussed is ground freezing, like how you can freeze the ground using different techniques, and by that how you can changes the or increase the strength of the soil. In the last module I explained you about the various applications of expansive soil and also how to construct the foundation on expansive soil. So basically the problem associated with foundation with an expansive soil is its less bearing capacity and also its swelling pressure. So when an expansive soil tries to swell, if you have provided any foundation on it, then it will try to push the foundation in upward direction. So that means it will reduce the bearing capacity of, suppose if you have provided a pile, then it will try to lift up the pile. So bearing capacity of the pile or load bearing capacity of the pile will get reduced. Similarly, if you have provided a shallow foundation like a slab foundation, then also it try to push the foundation in upward direction. So I discussed about what are the different mechanism or different techniques by which you can provide a foundation on expansive soil. Mostly if you are going for a shallow foundation, then what are the different type of foundation like waffle slab, and also you can provide continuous slab with smaller thickness. And also when you design for any foundation in an expansive soil, you need to take care of the swelling pressure, because the swelling pressure is the most critical factor which affects the foundation stability or foundation's bearing capacity. Because swelling pressure will try to push the foundation in upward direction. So that means if you are going to construct a pile foundation, suppose, so in that case you can provide I have a question that interaction between the expansive soil and pile be included in this course. I have not discussed in detail about the interaction between the expansive soil and pile. I have only explained you about how a pile behaves in the presence of an expansive soil. Particularly if it's a well foundation, then the well should be located in a stable zone. Stable zone means you know that if you are looking into an expansive soil, there is an active zone and non-active zone. Active zone means the water content will fluctuate more, and because of that, it will experience swelling and shrinkage. Whereas below that, there will be non-active zones or stable zone where water content will not change. So when you go for a foundation like pipe foundation, you need to provide the bulb in that stable zone. So therefore, the effect of swelling pressure will not be there on the bulb. So I have not covered the interaction between the expansive soil and pile. Just I have covered like how to design a pile foundation in an expansive soil. Like if it's a bulb foundation or a plain pile foundation, then how you can design what or where the depth or what should be the length of the pile and where it should be located. So those things I will explain, and also I will explain like if you are providing a pile, maybe you can provide a you can dig a large area or large diameter area where you can provide a pile, and in between you can put some compressible soil such that the effect of uplifting will be less. So those things I have covered, not in details, because again you cannot cover entire things in this 20 hours of lecture. And also I explained you about different engineering application of expansive soil. Particularly, we have seen or whatever we have mentioned so far, we are looking at the soil, expansive soil, in a more problematic manner. Like when we see or when we design this expansive soil creates problem to the structure, problem to the highway or pavement. But on the other hand, because of its swelling tendency and low hydraulic conductivity, it can be used at various engineering locations. Mostly when we need a impermeable layer around a structure. Say for example, nuclear waste depository or landfill liner. So there we can use the pile foundation. We can use the expansive soil, particularly bentonite or other kind of expansive soil, to have an effective seal against those. So in that I explained you about the use of expansive soil, particularly in the area of landfill liner and nuclear waste repository, and also how you can use different expansive soil, particularly bentonite, as a slurry wall and also as a drilling fluid in a pile foundation. Because when you drill or when you dig a soil with low strength, say for example when you are digging a soil in a loose sandy soil, so while digging the soil may get caved in, and if the soil gets caved in, it will not be effective. So therefore you need to stabilize the soil before putting actual reinforcement or other structures. So because of the thixotropy behavior of particularly bentonite or expansive soil, it is very useful in those scenarios. Say for example, when you put it into a pile foundation, and then it will create a filter cake all around the deep area, and therefore it will hold the soil and prevent the soil from being caved in. So you can put the reinforcement later on after digging the soil. So in that case, it can also act as a act to stabilize. It can act as a material to stabilize the soil. So those things I covered. Hopefully, all these courses or all these chapters have helped you in understanding or better understanding on expansive soil and how to deal with the soil. And also particularly if you are a research scholar or research or a student, then also it will generate some interest on you to study more about the expansive soil, because this is a huge chapter, and particularly the geoenvironmental engineering area, it's quite large. That means particularly in the terms of chemicals or in the terms of different contaminants, how is soil going to behave? So this thing is quite challenging, because the field study and the laboratory studies are quite different. So therefore you need to understand more in a more better way to particularly create a sustainable and effective way of treating the soil in a field. So I hope in that way this course might have helped you. And if you have any question also, please do not hesitate to ask me. Even after end of this course, you have my email address, which I have given you in the last lecture. So you can drop me an email, and I will write you back. And any question, please write it here. So because we have a few more minutes, I can answer to your question. And also, if you find some of the drawback or something lacking in the course, then also please try to, or please inform me, so that I can modify the course, or I can incorporate those suggestions. So again, please drop your question, anything or any suggestion. So that will be quite helpful to me also. Yeah, one question was asked to me. So, what is the effect of lime on the compaction characteristics of expansive soil? Mostly, when you use the lime, the maximum dry density of the soil will decrease. Maximum dry density will decrease means it will decrease from its 0 percentage of lines. That means, suppose if you take a lime, take an expansive soil, whatever ONC and MDD you will get, particularly MDD you will get, that will decrease when you add lime to it. Because when you add lime to an expansive soil, it will bind the particles and it will be difficult to compact. So therefore, the maximum dry density will decrease in comparison to a soil with 0% of lime. And similarly, if you compare with the optimum moisture content, the optimum moisture content will increase in comparison to a soil with a 0% of lime. So that thing you need to understand. And also, I have given you a graph showing the effect of lime on expansive soil. So in that case also you can see at 0% lime content, the maximum dry density will be higher, and when you increase the lime content, the maximum dry density will keep on decreasing, but after reaching a certain value, it will increase from the previous value, not from the 0% value. It will increase, but it will not go up to 0% value. Okay? So that means in that graph which I have shown, after 4% it will start to increase the maximum dry density. But increase means it will increase or it will be higher in comparison to 2% and 3%, not 0%. Similarly, when you see the OMC also, the OMC will increase in comparison to 0%. It will keep on increasing, and again after certain fraction of lime or certain lime content, it will start to decrease and then it will remain constant. So please do not get confused that with addition of the lime, the maximum dry density will decrease in the sense from 0% lime, and its optimum moisture content will increase. So if we have few more minutes, if you have any question or anything, please drop in. If you have any question, please drop a message here. Okay, if you don't have any question, then I'll stop it right here. And once again, thank you very much for attending the course and be a part of this course for last 8 weeks. Hope you have learned a lot and you can use those things for your practical application or maybe for your research work. And if you have any question, please don't hesitate to drop me an email or any suggestion if you want to give or any anywhere I have done any mistake or any typing error, please let me know so that I can correct it. Okay. So please drop an email to me if you have any queries or any suggestion or any doubt. And with this, I would like to thank all of you and all the best.